Dynamic SOQL is one of those topics where the gap between it works and it's safe is wide enough to cause real production incidents. This tutorial covers the full picture, what Database.query does, where the injection risk comes from, and the three patterns, bind variables, allow lists, and describe-based field lists, that eliminate those risks correctly. By the end, you'll know exactly which pattern to reach for in each situation. Static SOQL is great for most things. It's compiled at deploy time, so Salesforce validates your field names and object references before any code runs. But it breaks down the moment any part of the query is unknown until the code is actually executing. Think about a configurable report where the user picks which fields to display, or a utility class that needs to work across different object types. That's when you need dynamic SOQL, a query built as a plain string and executed at runtime. Here's the problem that most tutorials gloss over. When you build a query as a string, there's no compile time safety net. Salesforce validates the query at runtime, not at deploy time. So a malformed or malicious query won't fail your deployment. It'll fail silently or destructively in production. And the biggest runtime failure mode isn't a typo. It's a user passing input you didn't expect, and that input changing the structure of your query in ways you never intended. The core method is Database.query. It accepts a SOQL string and returns a list. You can declare the return as list subject, the generic base type, or as a concrete type like list account, and Apex will coerce it at runtime. The syntax looks like this: string SOQL equals select ID, name from account where industry equals / technology /, and then you return Database.query SOQL. That's it. The query runs, and if there are no results, you get an empty list, not a null, not an exception. Two behaviors worth knowing before you go further. First, if the query returns 0 records, you get an empty list, safe to iterate over, won't cause a null pointer. Second, if the query string is malformed, a syntax error, an invalid field name, an object that doesn't exist, Apex throws a system.query exception at runtime, not at compile time. That means your tests need to exercise the actual query, not just the logic around it. A static SOQL typo would fail the build. A dynamic SOQL typo makes it to production. Governor limits treat dynamic and static SOQL identically. Every call to Database.query or Database.queryWithBinds increments the same SOQL query counter, 100 queries per transaction. Dynamic SOQL does not get a separate pool. If you're building a loop that fires a dynamic query per record, you're going to hit that limit exactly as fast as you would with static SOQL. The only way out is bulkification, one query outside the loop, not one query per iteration. Now let's look at what SOQL injection actually is. Imagine a method that takes an industry name from a user and filters accounts by it. You build the string, select ID, name from account where industry equals technology. That looks fine. But what if the user doesn't pass technology? What if they pass technology or name like %? Your code concatenates that directly. The assembled string becomes where industry equals technology or name like %. The single quote closes the string literal early. The OR clause matches every record, and the query returns the entire account table, regardless of sharing rules. What makes this particularly dangerous is that it compiles perfectly. Salesforce can't see the injection at deploy time because the query is just a string variable. There's nothing to validate. The vulnerability only exists at runtime, when the user's input is actually inserted into the string. And the results don't throw an exception. You just get records you weren't supposed to return. If your code then passes those records to the UI, you've just leaked data. This is the Salesforce equivalent of SQL injection, and it's genuinely exploitable. The first fix you'll see in older code bases is String.escapeSingleQuotes. It prepends a / before every single quote in the input, which prevents the attacker from closing the string literal early. The code looks like string safe input equals String.escapeSingleQuotes, user input, and then you concatenate safe input instead. This works for string filter values inside quotes. But it does nothing for numeric comparisons, limit values, offset values, or order by columns. None of those are inside string literals, so there's no quote to escape. It's a partial fix, not a complete one. The preferred pattern is Database.queryWithBinds. Instead of inserting the user's value into the string, you put a placeholder, a colon prefixed name like industry, and pass the actual value in a separate map. The runtime substitutes the value as a typed parameter, never as SOQL syntax. The query parser never sees the user's input as part of the query structure. Injection becomes structurally impossible. The code looks like this. Map, string, object, binds equals new map, string, object, industry equals user input, and then Database.query.With.Binds, SOQL, binds, access level.user_mode. That map is where the value lives. The bind map uses string keys that must match the placeholder names in your SOQL string exactly. If your query has industry, your map must have a key industry. If your query has min revenue, the map key is min revenue. The values in the map are typed. You can bind a decimal, a set ID, a string, whatever the field expects. When you bind a set ID to an IN clause, that set can never break the IN syntax the way a crafted string could. And you can bind multiple values in one map for multi-filter queries, which keeps everything clean and readable. Database.query.With.Binds takes a third argument that static SOQL doesn't have, an access level enum. You pass either access level.user_mode or access level.system_mode. User_mode enforces field level security at the query level. If the running user doesn't have read access to a field you've selected, the query throws an exception rather than silently returning the field. System_mode bypasses FLS and runs as if you're an admin. Use user_mode for any query that runs in a user-facing context. Only use system_mode for internal system processes where bypassing FLS is intentional, and document why. Sometimes the field list itself is dynamic, a configurable report where the user picks which columns to show, or a generic utility that works across objects. The wrong approach is to take user-supplied field names and concatenate them directly. The right approach is to use the describe API. You call schema.getGlobalDescribe.get object API name to get the subject type, then subject_type.getDescribe.fields.getMap to get a map of every field on that object. From there, you can check which fields actually exist and which ones the current user can access. Inside your field building loop, for each field the user requested, you look it up in the described field map using the lowercase version of the name. SOQL field lookups are case insensitive. If it's in the map, you call getDescribe.isAccessible to check FLS. If it passes, you add fd.getName to your safe field list, not the raw string the user passed, but the canonical API name from the describe result. This is important. You're using the platform's own name for the field, which can't be a SOQL keyword or an injection payload, because it came from the schema, not from user input. The most common mistake with dynamic order by is concatenating the sort column directly. A user passes annual revenue, fine, but nothing stops them from passing annual revenue desk, select ID from accounts, and that breaks or manipulates your query structure. The correct pattern is an allow list, a hard-coded set, string of field names you explicitly permit as sort columns. Before you concatenate anything, you check contains on that set. If the value isn't in the set, you either throw an exception or fall back to a default. Never sanitize, validate, and reject. Limit and offset are a special case. SOQL doesn't support bind variables for these. They must be integer literals in the query string. But integers can't carry SOQL injection. The number 50 is just 50. The protection here is type enforcement. Make sure these are actual integer values, not strings that happen to look like numbers. Cast them, validate their range. Limit must be between 1 and 2000, offset must be non-negative, and then concatenate the integer directly. Once it's an integer type in Apex, there's nothing injectable about it. Testing dynamic SOQL doesn't require any special setup. You use @test_setup to insert records, call the method, and assert on results, exactly the same as testing static SOQL. Database.query and Database.query_With.Binds both see @test_setup data. The test respects the same governor limits as production, which means if your method would hit the 101 SOQL limit in production, your test will surface that too. Don't mock the database for these tests. The whole point is to exercise the actual query string against real data. Injection protection tests deserve their own test method. Don't just test the happy path. Write a test that deliberately passes a malicious string, something like technology, or name like %, and asserts that either an exception is thrown or the result set is correctly restricted to the expected records. If you're using allow lists for sort fields, Write a test that passes an invalid sort column and asserts a legal argument exception is thrown. These tests document your security assumptions and catch regressions if someone later changes the validation logic. Here's the full decision tree. If you're filtering by a user-supplied value, use a bind variable. If you're selecting from a dynamic field list, pull names from describe, check is accessible, use fd.getName. If you're sorting by a user-supplied column, validate against a hard-coded allow list, reject anything not in it. If you're setting limit or offset dynamically, enforce integer type and validate range, then concatenate the integer directly. If you're using an object named dynamically, validate against getGlobalDescribe or escapeSingleQuotes. Apply these 4 rules, and your dynamic SOQL is safe by construction. The full article, Session 59 at Real Syllabus, has every pattern as a complete, runnable class. The vulnerable version shown explicitly for reference, the escaped version with its documented limitations, the bind variable version, the describe-based field list builder, the allow-list guarded sort query, and a complete test class covering both happy path and injection scenarios. If you're writing dynamic SOQL in any professional context, this is the reference you want bookmarked. realsyllabus.com